Hi everyone, today I am going to present our work, Random Wins All, Rethinking Grouping Strategies for Vision Tokens. This work asks a simple but important question. When modeling long-range token interactions in vision, do we really need to carefully decide sparse attention patterns? Here is the main takeaway of this paper. We revisit the necessity of specially designed sparse attention mechanisms for vision tokens. Our central message is that a very simple random grouping strategy that can already work surprisingly well, which challenges a common assumption in this area. The motivations come from long-sequence modeling. To capture relationships among distant tokens, many sparse attention mechanisms have been proposed. However, most of them still depend on specialized hardware optimization or complicated implementations. So the key question is, are these specially engineered approaches truly necessary, or can a much simpler strategy achieve competitive performance? Our method is extremely simple. We use a random grouping strategy for vision tokens. The main advantage is that it is simple, fast, and general. Instead of designing complex hard-craft sparse attentions, we let random grouping create token connections in a lightweight way. At first glance, random grouping may seem too naive to be effective. Intuitively, we might expect structured designs to perform better because they encode more prior knowledge, but our experiments show the opposite. In practice, this simple random strategy brings significant improvements, which is a very interesting and somewhat surprising result. So, why does random grouping work better? We analyze it from four perspectives: position information, hand feature diversity, large receptive field, and the fixed random pattern. These factors together help explain why a simple random design can outperform more complicated alternatives. First, let's look at position information. A random grouping strategy can preserve and mix positional cues in a different way from manually designed sparse layouts. This helps the model avoid being restricted to overly rigid local patterns, and it may improve the way spatial relationships and encoded across tokens. Second, we study head feature diversity. The key idea is that random grouping encourages different attention heads to observe different token relations, which increases diversity across hands. The metrics and the results on this slide show that the random strategy leads to richer and more complementary hand behaviors, and this diversity is beneficial for representation learning. Third, random grouping naturally gives a model a larger receptive field. By randomly shuffling tokens, the model has more chance to interact with distant tokens rather than only nearby ones. At the same time, using a fixed random array allows the model to gradually learn stable sparse attention during training. So we get both broader connectivity and a learnable structure. That's all for my presentation. Thank you very much for your attention.